Welcome back, Algebra 2. This is Lesson 97, Advanced Substitution. We're going to start with your notes, star question 1. Normally, I would look at this system of equations and think this might be a good system for elimination. However, Saxon would like you to be fluent with substitution, even when it looks like it wouldn't be a friendly substitution problem. So the first thing I'm going to do is I'm going to figure out if one of these equations is a little easier to manipulate than the other. I noticed that my second equation has numbers that are all multiples of 2. So if I were to divide everybody by 2 on that second equation, it would be an easier equation to work with. So the first thing I'm going to do is divide everybody on that second equation by 2, and I'll rewrite that equation. That would give me x minus 2y equals -1. From there, I can isolate the x so that substitution can take place. So I add the 2y over to the other side. I get x equals 2y minus 1. Now I'm ready to go back to that first equation that was given, 5x minus 3y equals 9, and I'm going to substitute in this new equation, 2y minus 1. So I'm going to have 5 substitute in 2y minus 1 minus 3y equals 9. I'm going to go ahead and distribute that 5 across the parentheses. So now I have 10y minus 5 minus 3y equals 9. Combine any like terms. 10y minus 3y is 7y. Add that 5 to the other side. And this comes out pretty because I can divide both sides by 7 and get y equals 2. I'm not done though. I need to go back and substitute that in order to solve for y. So I'm going to come over to this equation that we've already gotten x by itself. That's going to be the easiest one to substitute into. So I have x equals 2, and then I substitute in 2 for y and have my minus 1 still. So this would give me x equals 4 minus 1, which means x equals 3. I'll write this as a system of equations, 3, 2, and that is my solution. Now we're going to try the practice question from your textbook. This is on page 404 in your Algebra 2 textbook. Use substitution to solve this system. 3x minus 5y equals 11. 2x minus 4y equals -6. Once again, I kind of key in on that second equation and notice that everybody on that second equation is divisible of 2, can be divided by 2. So I'm going to go ahead and do that. Divide everybody by 2 on that second equation. And that's going to give me x minus 2y equals -3. If I add the 2y to the other side, I'm going to get x equals 2y minus 3. I'm ready to take that new simplified equation and plug it into the first equation from the original set. 3x minus 5y equals 11. Plugging in for x, I'll have 3 parentheses, 2y minus 3 minus 5y equals 11. That would give me 6y minus 9 minus 5y equals 11. Okay, looking for like terms. I get 1y minus 9 equals 11. Add the 9 over. Y is equal to 12. Or excuse me, I added that wrong. Let's try that again. Y is equal to 20. Once I figure out my y, I'm going to go back to this equation where I got x by itself, and I'm going to plug in what my y value is this time. So I get x equals 2 times 20 minus 3. And that means x is equal to 40 minus 3. So x is 37. When I go to write that as a solution set, I get 37, comma, 20. That is my answer. All right, now we're going to go to the homework problems. We have a couple of them that are from this specific lesson. So we're going to start in with number 6, where we are once again using substitution to solve. Oops. So my system of equations is 2x plus 3y equals -7. Second equation is 3x minus 3y equals 12. All right, this time I don't see an equation where 2 can be divided across, but if you look at the second equation, 3 is able to divide across. So I'm going to go ahead and divide everybody by 3 on that second equation, and that would give me x minus y equals 4. And then further, I can just get x by itself by adding the y to the other side. So I get x equals y plus 4. And then I go back to the original first equation, and I'm going to substitute that in. So here's my first equation, 2x plus 3y equals -7. Plugging in for the x, I get 2, and it's going to distribute across. Y plus 4 plus 3y equals -7. That distribution gives me 2y plus 8 plus 3y equals -7. Combine those like terms. 5y plus 8 equals -7. Subtract the 8 over. 5y equals -15. Divide both sides by 5. I get y equals -3. Then I go back to that one equation where I got x by itself. Okay, so I'm going to go ahead and substitute in the new y. Y is -3. Add 4. That means x is 1. So my system solution would be 1, -3. I'll go ahead and highlight that here. All right, moving over to question 7, straight from your textbook. 4x minus 2y equals 8, and 3x minus 2y equals -4. It looks like we're going to be messing with that first equation this time because I see 4, -2, and 8 are all divisible by 2. Okay, so I'm going to divide the first equation by 2. When I do that, I get 2x minus y equals 4. And then I need to get y by itself, so I subtract the 2x over. But you'll notice that I have still a negative y, so I need to multiply everybody through by a -1. I get y equals 2x minus 4. Okay, then I'm ready to substitute that into my second original equation. Here's the original, 3x minus 2y equals -4. And I'm substituting in for y. I get 2x minus 4. And then I'm going to distribute that -2 across. So I get 3x minus 4x plus 8 equals -4. Combine my like terms here, and I get -x plus 8 equals -4. Subtract the 8 over. -x equals -12, and therefore x equals +12. My solutions for x is 12. It needs to go back in to this equation where I got y by itself. So I get y equals 2, plugging in 12 for x, minus 4, 2 times 12, that would be 24. Subtract 4, so that means y is equal to 20. And then when I put them together, as I said, I get 12, 20 as my solution. All right, then I want to go to question 12, because we seem to struggle quite a bit with our graphing. So I'm going to go through this one the original setup, I have x minus 2y is less than 2, and then I have y is greater than or equal to 0. All right, well, that first equation, I need to get it into a y equals mx plus b format. So the first thing I'm going to do is subtract the x to the other side. That would give me negative 2y is less than negative x plus 2. And then I'm still not with y by itself. I have to divide everybody by a negative 2. When I do that, since I'm dividing by a negative, it will flip that sign. Okay, so I'm dividing this side by a negative 2 and everybody on the right side by a negative 2, and it will flip my sign as well. That would produce y is greater than 1/2 x minus 1. All right, now I'm going to choose a color for that first graph. I'm going to pick red, and I'll go ahead and start walking through how to graph that. Since it has a minus 1 at the end, that is where I start on the y-axis. That is my begin. And then this 1/2, that is how I move. So I go up 1 and right 2. Okay. And I could also go down 1 and left 2. Now I'm ready to make my line, but notice that it is dashed. Okay, it is a dashed line because this symbol right here does not have an equal bar. Okay, so it's a dashed line. It also shows that it is a greater than symbol. And so what that means is when I go to highlight, I have to shade greater or more than where I am. So I'm going to go up and shade above that dashed line, everything above the dashed line. Okay. All right, and then I'm going to choose a different color to work on that second equation. So I'll choose green, and that's going to go for this second equation. Y is greater than or equal to 0. All right, that's actually a horizontal line. There's no slope, and it takes place hitting across the 0. This one is going to be a solid line. So across the y-axis, or excuse me, the x-axis here, I'm going to draw a solid line. And it is solid again because it has that equal bar underneath. And then I need to highlight above because it says greater than or equal to. So anything above this line would be this direction. All right. From here, I'm going to actually highlight with a darker color just to make sure you guys are able to see where do the two shade together. And that is this area up here. So if you were asked a question of what is a point that is part of the solution set, then you could choose any point in that dark kind of puke brown area up at the top. So I'm going to pick a point that's nice and safe. I'm going to say this is clearly in the double shaded area. Both red and green shade and cover that dot. And that dot is at 2,5. Now, Saxa doesn't ask you to do that, but Delta does ask for you to put a point in that solution set to make sure you're understanding it. So on the homework, you don't have to label any dots, but understand in Delta that you have to give a dot. Now, how many dots are possible? Actually, an infinite number of dots are possible, but just pick one that is clearly in the double shaded area. Hope that helps. See you soon.